Oftentimes when artists notice an unexpected slowdown in Nuke, it's due to the inefficient use of the bounding box. The bounding box is a subregion or domain of definition or data window that defines the active pixels in an image. For example, in this case, we have this ladybug flying around, and really this area around the ladybug is the only area that actually has active pixels. The rest is just black. Let's look at a case where this could really hurt us. This ladybug was rendered in Modo, and it has a bit of specular noise in it due to poor settings or inefficient sample settings. And I don't have enough time to re-render it. So let's say I'd like to just recycle this image, try to salvage it in 2D by using a median filter to kill this noise. So I'm going to drop down a median filter to try to eat some of those small speckles and salvage this render. Now you'll notice Nuke is spending an awful lot of time processing pixels that don't really even have image in them. It's just black, flat areas. Now it finally gets to this ladybug and processes it. So obviously this is an inefficient use of resources. If we could define this area of only active pixels, then Nuke would go a lot faster. So let's disconnect the median node. Now we can do this using the crop node. This is the reason that the crop node does not reformat the image by default, because its default behavior is to simply redefine the domain of definition. So I'm going to hide the overlays here, or I'm going to hide that there so that we can see now it's redefined the bounding box or the active pixel area, the data window if you want to call it that. All these pixels out here are being disregarded entirely, though Nuke is still tracking their position within the format. So now if we attach the median node, you'll see it's much quicker, almost too fast to notice. So let's move to another frame. Went a little too far because it moved out of the bounding box, and this is the problem. If we wanted to use this workflow, we'd have to hand animate this crop, but that's not really necessary. Nuke has a tool that will help us find this crop area automatically. It's called a curve tool. So I'm dropping down a curve tool, and if we put it in auto crop mode, I'm going to switch this to only process the alpha channel. That should speed it up a little bit. It will go through every frame and find the active pixels and create a set of curves for us to help us crop them. So here we go. Go. Here are the curves that it's created. But by default, it does not do the cropping. So we still need to drop down a crop node and copy those animation curves in. We can either copy them or expression link them. I'm going to copy them by holding down Shift and dragging this over. So now I've copied the animation curves into the crop node. And I could safely delete this curve tool if I wanted to, so I will. Now you can see it is automatically cropping it for each frame. So when we attach our median, it's only processing the area in the crop window. This is a useful enough workflow that Nuke has shipped with a script to do this for some time. So if you click the node that you would like to auto crop, hit X, and then you'll have to select Python, and the name of the script is Nuke scripts dot autocrop, and you'll have to put these open brace and close brace afterwards and hit OK. Nuke will then repeat the actions that I just did manually. It will run the curve tool, and then it will copy the autocrop curves into a crop node and then delete the curve tool for you. There we go. It's now done all those things in an automated way. You could connect that to a button here on your own if you like, or bind it to a hotkey. Another way that you can achieve this is by using the auto crop mode of the right node. So let's set up a right node. So if you check auto crop, it will do this per frame as it writes out each frame. One thing to keep in mind though when you do this is this does add some overhead to the right node. And so it's not really a great idea to leave this on active all the time, but if you wanted to do it as a batch process beforehand or as a post process to your renders, if your renderer can't create the bounding boxes for you, which are supported by the EXR format, by the way, then you could do that. I've used it a few times in production where we had very, very high resolution images because we had to render them at a high resolution. And by just doing the auto crop and shrinking the active area of pixels, I was able to speed up the composites considerably, even though we were rendering and compositing at 4K. Here we go. Let's render some frames out. We'll only render, let's say, 20 or 30 frames out. And then we'll read these back in. And you can see that Nuke has created bounding boxes for us at the moment that it wrote the file to disk, which is very convenient. There's some other tools worth mentioning that you can use for processing the bounding box. So let's say that you had, this is just the alpha channel only, a clean alpha channel rendered for this ladybug. And you already had your bounding box created that you knew matched another image. There is a tool called copy bounding box that you can use to copy the bounding box around. So copy B will copy the bounding box from A to B. So now I've copied it from the one that I generated with the auto crop option on the right node, copying it over to this alpha channel that was written out as a clean AOV separately. And then there is also a tool for manipulating the bounding box after the fact called the just bounding box. So if you need to grow or shrink the bounding box, you may use this to grow or shrink the bounding box. This is sometimes necessary with certain filters because they'll filter a little too large than the bounding box, and you'll get maybe artifacts like this because they've filtered a little too much. But if you adjust the bounding box before applying them, if you notice a problem like that, then you will have enough of a buffer outside with your bounding box before the filter hits, so it doesn't create some unexpected result.